In today's video, we're going to be looking at how we use the relationships present in a 30, 60, 90 triangle to find the lengths of missing sides. So in this problem, or in any of the problems of this type, you're going to be given the length of one of three things. You're either going to be given the length of the shorter leg in the triangle, and remember your shorter leg is the one that is always opposite the 30-degree angle. So we could be given the length of the shorter leg. We could be given the length of the longer leg, which is the leg opposite the 60-degree angle, or we could be given the length of the hypotenuse, which is of course the side opposite the right angle. In either of those situations, you're given one length and you're asked to find the lengths of the other two. So in this video, we're going to go through some possibilities for the types of problems that you can see using this relationship. And we're going to be doing that using what we see here in these equations. We know that from the ratios proven in a previous video, that the length of the leg opposite the 30-degree angle, the shorter leg, is always going to be half as long as the hypotenuse. So if we take the length of the shorter leg and multiply it by 2, it produces the length of this hypotenuse, 2x. Likewise, if we take the length of the shorter leg and multiply it by the square root of 3, it produces the length of the longer leg. And those are the relationships we're going to be using. So let's look at our first example. In this case, we're given a triangle with a shorter leg length of 7. And we're asked to determine then the lengths of the longer leg and the hypotenuse. So in this case, that 7 represents the shorter leg. We know that because it's opposite that 30-degree angle. So here we'd take the length of the shorter leg times 2, and that gives us the length of the hypotenuse. Here we know 7 times 2 is 14, which means 14 is the length of this side. Likewise, to find the length of the longer leg, we take the length of the shorter leg times the square root of 3. So here we're going to take 7 times the square root of 3, and that produces the length of the longer leg. Now here with the 7 and the root 3, these two, when we multiply them together, there's no simplifying that we can do. So it simply becomes 7 square root 3 for the length of the longer leg. So in the case of given the short leg, that's usually the simplest process in any of these. It's a matter of simply substituting in place of the short leg in these equations and using that then to find the lengths of the other two sides. Now, aside from being given a whole number value, you could also be given for that shorter leg a length that's either in fractional units or, as we see here, something that involves a radical. But the process remains the same. So we know this 8 root 3 is the shorter leg because it's opposite the 30-degree angle, which means it can substitute in both of these positions. So here, 8 root 3, the length of the shorter leg, times 2 would give us the length of the hypotenuse. Now, in the case of multiplying the 8 root 3 and the 2, we multiply the whole number values together. So the 8 combines with the 2 to produce a 16, and the square root of 3 remains unaffected. So the length of our hypotenuse in this case is 16 root 3. Okay, now let's go to this second equation. Multiply the length of the shorter leg times the square root of 3 to produce the length of the longer leg. So here we take this short side, 8 root 3, multiply by the square root of 3, and that should give us the length of the longer leg. Okay, so here the 8 is unaffected by this radical 3, so that stays an 8. Now consider what happens when we multiply the square root of 3 times itself. The square root of 3 times the square root of 3 produces the square root of 9, which can be simplified. So the square root of 9, we know that that is simply 3. Remember, these are being multiplied together. So we're taking the 8 times the 3, which tells us the length of the longer leg would be 24. So the easiest process in any of these is when you're given that short length, that shorter leg length, the side opposite the 30-degree angle, that we can simply double it to get the length of the hypotenuse, or multiply it by the square root of 3 to get the length of the longer leg. So let's look at another scenario of what you could be given. In this case, we're going to be given the length of the hypotenuse as 20. So what I'd want to do with that is then substitute it in here into our equation in place of the hypotenuse and determine the length of the shorter leg. Now I know from reasoning that if the short leg times 2 has to be the length of the hypotenuse, then if I divide both sides by 2 or I multiply by a half, another way to rewrite that relationship would be to say that the short leg has to be half as long as the length of the hypotenuse. So in this case, if the hypotenuse is 20, half of that tells me that the shorter leg must have a length of 10. Okay, so this is now 10. Now going forward into the other to find the length of the longer leg, we're going straight back into this equation that we had before. The short leg times the square root of 3 has to give you the length of the longer leg. And in this particular case, the 10 and the radical 3, there's nothing we can simplify there, so it becomes simply 10 square root 3. So it's a matter of just reimagining what this equation would look like, rewriting it in an equivalent form that's going to allow us to simply find the length of the shorter leg. Once you have that shorter leg, then it's just a matter of substituting to find the length of the longer leg. Okay, let's look at a similar exercise. In this particular one, we were given a hypotenuse that was even. It was easy to multiply the 20 by a half or divide it by 2 if you want to see it in that form. What do you do if it's not even? And that's what we're looking at here in this example where we have a hypotenuse of 35. The process still remains the same. So as we said before, the length of the shorter leg is going to be half of the length of the hypotenuse. Now in this case, the length of that hypotenuse is 35. And there are a number of ways that you can write that half of 35. We could write it as 35 over 2. We could write it as 17.5. Or we could write it as 17.5. Any of those three forms is equivalent, and therefore any of these three forms can be used in this situation. I am partial to the improper fraction notation myself, but neither of them is incorrect. It may just have to be a matter of what's acceptable in the context, or with certain teachers, different expectations happen. So here, I know the length of my shorter leg is 35 over 2, or 17.5. Now, we still need to find the length of that longer leg, and to do that, we're going back to this relationship. So we're taking this shorter leg, which we said was 35 halves, or 17.5 if you want to go that route, and we're going to multiply it by the square root of 3. Now keep in mind that I'm envisioning, although I don't see it, that square root of 3 is the same as square root of 3 over 1. So if you need to see it in that form, you can. So that now when we multiply, we can see that 35 times the square root of 3 becomes 35 root 3. And in our denominators, we get simply a product of 2. Now you would want to make sure, remember this is the length of the longer leg, you would want to make sure that none of this can simplify. Here the 35 and the 2 don't reduce. There aren't any radicals that I can simplify. So the length of this longer leg then becomes 35 root 3 all over 2. So it is possible to have improper fractions in place. Now, if I had used this 17.5 or the 17.5 in place of this 35 over 2, then what that would have produced here, if I take that 17.5, I'm going to write it as 17.5, and I multiply it by the square root of 3, then I could leave it in this form and say that's the length of the longer leg. It is more common in things that I've seen to see it in this form, but this is the equivalent to it, so it's not necessarily wrong, it's just different form. Great. Another possibility for what you can see on the hypotenuse, we looked at an example with an even whole number on the hypotenuse and now an odd. What happens when the value on the hypotenuse is a radical? In this case, the square root of 7. So we're going to start it the same way. We know the length of the shorter leg is half as long as the hypotenuse. Now, in this case, that means half of the square root of 7. So here again, I want to think of that square root of 7 as being the square root of 7 over 1. So when I multiply across, that tells us that the length of the shorter leg has to be the square root of 7 over 2. Square root 7 over 2. Okay, same process as before. Now we're going to take that shorter length, multiply it by the square root of 3, and that's going to produce the length of the longer leg. So the square root of 7 over 2, the shorter leg, times the square root of 3, and that's going to give us the length of the longer leg. Okay, so there again, imagine that square root of 3 over 1 if you need to, and we multiply across. Root 7 times root 3 produces a square root of 21, and in our denominators we end up with a 2. Now you do want to make sure that your square root, especially in any of these that involve a radical, make sure that it's simplified. In this case, the square root of 21 doesn't simplify, it stays in that form, which means here we don't have anything that we can reduce. So the length of the longer leg becomes the square root of 21 over 2. So we've now looked at examples where you're given the length of the shorter leg, and we've looked at some examples where you're given the length of the hypotenuse. Last thing we need to look at are those where you're given the length of the longer leg. And in this case, we're going to start with one where the length of the longer leg has a radical 3 in it, just like we see in the original form. Okay, so if we're going through sheer pattern recognition, comparing this x root 3 to this 11 root 3 tells me that x must have a value of 11, which would mean the shorter leg in this case is 11. But that approach doesn't always work because you're not always going to be given a value here on the longer leg that is some number times the square root of 3. So what we do instead is we're going to use this second relationship and use that to determine the length of the shorter leg. So let's kind of look at it algebraically. We're going to use this second equation. The shorter leg, which we don't know at this point, times the square root of 3 has to equal the length of the longer leg, which is this 11 square root 3. Now, algebraically, we know that if two things are being multiplied and we're trying to isolate one of them, the way we do that is dividing both sides by the square root of 3. In this case, what's going to happen is the square root of 3's are going to cancel on the left, leaving us with the value of that shorter leg, which is what we're after. And they cancel on the right, which is why we end up with that 11 that we saw through our pattern recognition. Okay, so the length of the shorter leg is 11. Now we determine the length of the hypotenuse, and that's just a matter of going back to the first equation. The shorter leg times 2 produces the length of the hypotenuse, which means in this case the hypotenuse has to have a length of 22. Now that's pretty simple if the side length given is a radical already. Let's look at an example where it's not, which is the case here. So the same process applies. We're going to start with this second relationship. The short leg times the square root of 3 has to equal the length of the longer leg, 21. And there again, to get that short leg isolated, we're going to divide by the square root of 3 on both sides. Now we mentioned in a previous video that anytime we have a radical in the denominator, we have to rationalize. And rationalizing involves multiplying that fraction, both the numerator and denominator, by that radical that's in the denominator. So here I want to multiply by the square root of 3 over the square root of 3. Effectively, we're just multiplying by 1. Okay, so in our numerator, what we're left with whenever we multiply, the 21 root 3 doesn't simplify. But the square root of 3 times the square root of 3 produces the square root of 9, which simplifies to simply 3. Now, in this case, that will reduce, dividing those whole numbers, 7 root 3 for the length of the shorter leg. Now go back to the first equation, multiply the short leg times 2, and that'll give you the length of the hypotenuse, which in this case is 14 root 3.